All right, welcome to the Santa Fe High School Geometry Unit 2 practice test video. We're happy that you have chosen to spend some of your time getting ready for your test by watching this video and checking over your answers. In fact, before we begin, we're about to show you the answers for all of the questions. We would highly recommend that you actually work out as many of the problems on your own as you can. That way you'll know which ones you feel good on and which ones you need some extra help on. That's a really important thing to know. If you know you're weak on a certain problem, you can spend more time watching that problem. In fact, if you really are strong on a problem, you could just skip that part of this video and not spend the time on that and spend it on some other problem that you need help on. So if you haven't worked out as many of the practice test questions as you can, I'd say pause this video, go work them out, and then come back when you have as many of them done as you can. Alright, in just a moment we will show you the answers to the first two questions, so hopefully you can check the work that you already did. I'll only have the answers up on the screen for a few moments, but you can pause the video, right? So just pause it, and when you've checked all your answers, maybe mark the ones that you missed so you can know to focus on those. Then I'll show you the rest of them. Okay, so in a moment, here come the answers to the first two pages. Alright, laid out on the screen now are the answers to the first 10 questions on the first two pages of the practice test. If you need more time to check your answers, just hit pause. Up next, we'll show you the answers to the next batch of problems. Okay, here are the answers to numbers 11 through 19. Just like before, pause the video so you can look over your answers and see which ones match and which ones don't. Alright, here are the answers to problems numbers 20 through 22 on the last page. Alright, next up we will work out each problem and explain why that's the right way to do it. I'll also remind you that this video is recorded in high definition. You can go down to the settings and make sure it looks nice and sharp. And if you want to go faster or slower, there's ways in YouTube to speed up the video or to slow it down if you feel like I'm talking too fast. Alright, here come the problems. Alright, here's number one. They tell us we are going to be reflecting, so the transformation we're going to do on this problem is a reflection. And of course, to do a reflection, we need the line of reflection. And they tell us that that line of reflection will be the y-axis. So before I really get into this too much farther, I'm going to make sure I highlight the line of reflection. So here is the line that I'm going to use. Alright, and basically we just have to reflect this triangle PQR in the first quadrant over across the line into the second quadrant. And of course the basic rule is however far a point is from the line of reflection, it's going to bounce that same distance on the other side. So we'll notice that point P is how far away? 1 unit away, so that means I'm going to go 1 unit on this side. So here is my new point P prime, and what are its coordinates? It's at -1 and up 2. So -1 up 2, there's my first point. Okay, how about point Q right here? How far away is it? 1, 2, 3, 4. So that means I'm going to go 1, 2, 3, 4. There is my new Q. I'll call it Q prime, and it's at what? -4 and 1, 2, 3, 4, up 4. So -4, up 4. And finally, point R is over what? 1, let me get a different color. 1, 2, and so I'm going to go over 1, 2. There's the spot. So it's going to be R prime is at what? -2 up 5. -2 up 5, and if I want to make sure everything looks the way it's supposed to, I would draw in the triangle. Because reflection is a rigid motion, these two triangles should look identical to each other, and if they do, I probably did my reflection right. If they don't look exactly the same as each other, then maybe I counted wrong or I accidentally didn't go straight across, something like that. Alright, that was number one. Alright, number two. This time we are going to do a rotation. Okay, and if they ask you to do a rotation, they have to give you a couple more facts. They have to tell you how much. Looks like we're going 90 degrees. They also have to tell you in which direction. Looks like we're going to go counterclockwise. And finally, they have to tell us around which point we're going to spin, and in this case, we're going to spin around the origin. Alright, so the very first thing we should do is plot the point that we're spinning around. So if I'm spinning around the origin, I'm going to plot this point right here. I guess before I go too much farther, I'll point out that your teacher might have taught you a different way to do this. And if you're more comfortable with the way your teacher did it, you should just do it that way. I'm going to show you the way I teach my students. Maybe you'll like this way better, and if you want to switch to it, there's lots of good ways to get these answers right. So here's just one way to do it. Alright, well, I guess first thing we maybe notice is that if I really rotated point B around the origin, point B is on the origin, so it's just going to spin there and stay in the same spot. So B prime's points will stay exactly where they're at. But how about point A over here? Here's what I do. I connect the point that I'm spinning around with the point that I want to spin with a little L-shaped figure. And the idea is, as this thing spins around, it stays the same size. So how big is this thing? It's like 4 by 2. And if we went counterclockwise, we'd be spinning up this way. This would flop up and still be up 4. And this part would flip up and be sticking out right there. And using these L-shaped figures, you can figure out where these points will move to during a rotation. So this point would be what? A prime, and it is at what, -2 up 4, -2 up 4, and we just have one more point to figure out. Let's do point C. So this time I'm going to go up and over. So that's what, 1, 2, 3, also 4 by 2. And if I flip that part down, it's going to be what, over 4 and up 2 would get me to this spot right here. And that point is what, C prime, and it's at -4 up 2, -4 up 2, and if I draw in my triangle, it should look just like a rotated version of the first one. And it does. In fact, it almost looks like a reflection, but it's not. We know that it's a rotation. Alright, number 3. Number 3, we have a couple of lines that are crossing. So we've got this line here, and it is intersecting with this line here, and whenever that happens, we get some special angles. In fact, this problem wants us to take a look at what? Angle 1 and angle 3. So we're going to look at angle 1 and angle 3. And I should notice that these two angles are across from each other, and that means that they are the kind of angles that we call vertical angles. And you should have studied in your geometry class that those vertical angles, no matter what, always have to be congruent to each other. So like if this one was 80 degrees, this one would also be 80 degrees. So this problem makes us do a little algebra. They give us some algebraic expressions. We're going to take that 7x minus 23 degrees and this x plus 31 degrees. And what has to be true about these two angles? Well, they have to be equal. So what would I say about these algebra expressions? I would also say that they are equal. Like whatever the angles' relationships with each other are, you just express that in an equation. Alright, next up we would simply solve this equation. I'm not going to show you all the steps of the algebra, but here's what would happen. So that's what you would get once you solve the equation, and of course this problem just asked us to solve for x. So you get done solving, you have x equals 9, you gave them what they were asking for. Alright, number 4 gives us a pre-image, and of course this one down here has the prime marks on it, so it's the image, and they're telling us, well, it's basically going to take more than one transformation to get the pre-image to kind of land on top of the image, to carry it onto it. So they're asking us which combination of transformations would actually work to get this one right on top of its image. Like which sequence of transformations or composition of transformations must have occurred. So let's see. This first one says a reflection and a rotation. So you'll notice if I kind of had a little copy of this one, I could reflect it over. But would I rotate it? Does this look like a rotation? Does everyone notice that this is pretty much a reflection? So we could either translate it down and then reflect it over, or we could just go ahead and reflect it and move it down, but there's no rotations in this problem. So if I look at all these choices over here, Reflection and rotation, well, this doesn't involve a rotation, so it's not A. Translation, like if we moved it down and then flipped it over, that would work. That would be a good one. How about rotate it and then, no, we don't want a rotation, so that one's no good. And what if we reflected it first and then translated it down? That would work. So our two answers this time would be B and D. And of course, while you're taking the test, you should always keep an eye out for these choose all that apply problems. If you have a highlighter, I would highlight it. If you don't have a highlighter, I'd like maybe underline it with my pencil. You don't want to just pick one answer. You'll at least get half of the problem wrong. There's usually two answers. Sometimes there's three answers, but there's always more than one. All right, here is problem number 5. They give us a pre-image and an image, and they ask us to describe the transformation. I just noticed there's a typo in the word transformation. But we've basically got 3 transformations, so is this a translation, a reflection, or a rotation? And I don't think you have to look very hard. You can see that one figure is flipped over on the other one, so this is definitely a reflection. Now, if you just write reflection on the test, you won't get full credit. Okay, so I'm going to write reflection, but I've got to say more than that. In fact, to do a reflection, what must you have? Well, you have to have a line to reflect over. And so if you say that you're going to do a reflection, you have to tell me what line you're reflecting over. Just like if you say something's a rotation, that could have been an answer here. It's not, but let's say it was rotation. You'd have to actually tell me 3 things. You'd have to tell me what point needs to be spun around, what direction, clockwise or counterclockwise, you need to rotate, and then how far, like 90 degrees or 180. But anyway, with reflection, all we have to do is point out the line that we're reflecting over. So we kind of have to eyeball this. Obviously, these 2 figures have to be equidistant from our line of reflection. So where could I draw? It looks like we need a horizontal line. Where could I draw a line so that both of these are the same distance from it? Okay, and hopefully you can kind of see if I draw that line right there, how far is this point from the line? Well, isn't it 2 units? And how about this point right here? Isn't it also 2 units? So, and maybe just to make sure, how far is this one? 1, 2, 3 units, and that means this one down here would have to be 3 units. 1, 2, 3. So I think I've got the right line of reflection, right? All the points in the pre-image are equidistant from the points in the image as far as that line goes. So the last thing I have to do is figure out what line this is. So it's clearly a horizontal line. And maybe what I will do is I will put a couple points on there. What if I pick this point and this point? So those are 2 points on this line that I've decided is the right line for this reflection. And what are the coordinates of this point? Isn't it at 1, -1? And where's this one at? 3, -1. And can everyone see that the thing that's the common element in these 2 is that the y values are the same? In fact, what do I need to say here? Reflection across. What are the same? The y's are. So across the y equals, and what does the y equal? Well, it's -1. Okay, and if we wrote out that this is reflection across the y equals -1 line, we would have worked it out correctly. And just to repeat it, if you only say reflection, you wouldn't get full credit on that answer. Okay, so I've got 2 points on here. What point would this be? This is over 1, up 2, over 1, up 2, and this is what? Over 1, down 2. So what we would look for is where do we have the same number? Do you notice that the 1s are the same? And what are those? Those are the x values. The x values are both 1. Right? The y values are different, so that's not the thing that stayed the same. This is an equation where the x values are always 1, so the right answer would be letter choice B. This is an x equals 1 line. All right, here's problem number 6. They show us a transformation. Clearly it's a translation where the triangle's just slid over. And they want to know which of these coordinate notation directions accurately describe the transformation or the translation that took place. So basically what we need to do first is just pick one point. So you could pick A, B, or C. It really doesn't matter. I think I'm going to pick point C right here. And basically, I would match that up with C prime. And now I'm just going to figure out like what it took to go from C to C prime, and that will tell me like which direction should have happened. So it looks to me like they needed to move over to here. So what is this, X or Y? This would be X, right? And how far over did it move? 1, 2, 3. So that's obviously an X plus 3. Okay, and then they moved that point up to that spot, so that's what, 1, 2, 3, 4, and because I'm traveling up, that would be a Y plus 4. So this coordinate notation, you would take your pre-image points, whatever they are, and it would map onto a spot that you would arrive at by doing X plus 3, Y plus 4, and that looks like it would be letter choice C would be the answer. Okay, if you had used point A and moved it over to A prime, you would have got the same answer. All those points move the same way. All right, number 7 gives us this four-sided figure and asks us, if we rotated this thing around the origin, which rotations would map it onto itself? In other words, the rotation would kind of make it totally line up. So I've got this version and over here, and here's kind of what you have to do, either with patty paper or with just your imagination. You kind of just need to imagine what would this look like. So this would be a 90-degree rotation. Do those map onto each other? No. What about a 180? Does that perfectly line up on each other? Nope. What about 270? Right there? Nope, that doesn't either. But of course, all rotations of 360 degrees would make it. And so that would be the answer for this one. So you just kind of have to imagine that, or see if your math teacher will give you a sheet of patty paper to kind of check that out. All right, number 8 asks us to calculate the length of segment PR, and I guess if we are looking at those directions, the most important word up here is the word length. So in other words, they want us to figure out how far is it from point P all the way over to point R. And what they did for us is that they have given us the coordinates of the endpoints. All right, so what should we do if they want us to figure out the length? Well, we should use the length formula that we learned way back in Unit 1. In other words, if we want to know the length of segment PR, it's a big old square root, and what we're going to do is what? Subtract the x's from our endpoint. That's going to be the -3 and the 3. We're also going to subtract the y's, so we'll subtract those. That's going to be the -2 and the 1. When we're done subtracting, we have to square. And right here in the middle, do you remember what that's supposed to be? It's supposed to be plus. So we put those 4 numbers into those 4 spots. Does this mean you have to have the length formula like memorized for this test? You do. Maybe you already had it memorized from our very first test. So if you do already have it memorized, you're in good shape. But to get this problem right, you do need to know the length formula. So here I go. I'm going to work this out. The length of PR is equal to, and sometimes what I do is I just like fill out my formula, and then I can just pop the numbers in. That sometimes prevents, sometimes we have minus and negative, and if you don't write it out ahead of time, you can mess up. So I got my blank formula. The good news is, does it even matter what x you put where? It doesn't matter. So x is subtracted, that would be -3, take away 3. And for the y subtracted, that would be, what, -2, take away who? 1. All right, I got all my numbers in there. Let's just start doing the work. So -3 minus 3, that would come out to be -6 squared. And -2 minus 1 comes out to be -3 squared. And that means I have the square root of, what is -6 times itself? It's positive 36. And -3 times itself, remember this is going to come out to be positive, what would that be, 9? And that means PR has a length of square root 45. And because 45 is not a perfect square, it's not like 64 or 121, one of those numbers you get by multiplying something times itself, you would just actually leave that as your answer. From here all the way over here has a length of square root 45. And what is square root 45? That's square root 45 is between what? Square root 36 and square root 49. So this would be 6 and this would be 7. So square root 45, that distance is about what? Like 6.6 or 6.7? That's about how far apart those 2 points are. That would be the length. All right, number 9. We have a triangle, and we're going to rotate it 180 degrees counterclockwise around the point 1, -1. And they even did us a little favor and plotted that point. So we need to graph the image and then find the coordinates of all the image points. So here's what I'm going to do. They've already plotted this, so I'm going to connect A with an L-shaped figure. Okay, and now to go counterclockwise, a clock spins this way, so I'm going to spin this way. In reality, a 180 degree rotation really doesn't matter which way you go, but we would go 180 degrees. So this thing is 2 by 1. It would still be 2, and that 1 would be sticking out over here, so that would be the spot of the point. That's going to be A prime, and where is it? It's at 0, -3. There's my first point. Okay, point B. So point B, I'm going to run over and then up. That's what? 1, 2, 3 by 1, 2, 3, 4. And if this goes 180 degrees, it's going to be right here. 1, 2, 3. And that would be swinging down. 1, 2, 3, 4. That would give me this point right here. This is going to be who? B prime. And it's at what? -2. And down 1, 2, 3, 4, 5. So -2, -5, and finally point C, I'll use a different color. I think I'm going to run over and then up. So that's what? 1, 2, 3, 4, 5, and up 3. So if that goes around 180 degrees, it's going to be over here. 1, 2, 3, 4, 5. Did I do that right? 1, 2, 3, 4, 5. Oh, I went a little too far. So let me come back a little bit. There's 5 right there. And now what? Down 3. 1, 2, 3, there's the spot. So there is C prime, and it's over what? 1, 2, 3, 4, -4, and how far down? 1, 2, 3, 4, -4, -4, and I will draw in my triangle. Now here's a good time to check to see that I did this right, because this triangle should look exactly like the triangle I was just starting with, and it does. They look perfectly rotated. All right, so that's how you would do that. Remember, if you're going to use this L-shaped technique, it really doesn't matter which way you go as long as you go along the grid, and then you just have to imagine in your eye that whatever shape that L is, it stays that shape as it goes through that rotation. All right, number 10 tells us we have a point O and it's between F and P. So this is one of those geometry problems. Doesn't have a picture, so we should draw our own. So here's my picture, and I should call this what? The endpoints would be F and P. All right, and O is between. Now be careful, between does not mean right in the middle. So I think I'm going to put point O right here. I really don't know where it's at, just somewhere between. That means it's on the segment between them. All right, and now I should take some of this information and label the picture. So from F to O is x plus 8, and from O to P has a length of 2x plus 4, and then the whole distance all the way over is 36. The segment addition postulate says if you have a big segment that's made out of smaller pieces, you can just add up the small ones and they equal the big one. So we would get what? This segment, x plus 8, plus the length of this segment, 2x plus 4, must all add up to the whole thing, which is 36. All right, at this point we'd combine some like terms, so x and 2x make 3x. Positive 8 and positive 4 would add up to positive 12 is all equal to 36. If I subtract 12 from both sides, 3x now equals 24, and when I divide by 3, x is 8. And that's all they asked for us to solve for x. So draw the picture, add up the small parts of the segment, and let it equal the big part, and you'll be in good shape. Number 11, we have two lines that are intersecting again. So here's line Q, and here's line P. And and when they cross, they create these four small angles. Some of them look a little obtuse, like angle 1. Alright, so this problem involves what? Angle 1 and angle 2. Angle 1 and angle 2. So we're talking about angle 1 and angle 2. In other words, we're talking about this obtuse angle and then this acute angle right here. And the big thing that we have to notice is that the obtuse angle and the acute angle end up making a perfectly straight line, right? They make this straight line right here. In other words, together they make half of a circle. And that means if we add them up, what is half of a circle? 180 degrees. So 8x plus 11 degrees plus the other angle, 3x minus 7 degrees, is all equal to half of a circle. You really just have to kind of look at what you're dealing with. If you start making guesses, like if you're not paying attention whether these are vertical angles or whether they're right next to each other, that's no way to do this problem. You got to know what you're looking at. So it all adds up to 180 degrees. Alright, combine some like terms. We get 11x, plus 4 is equal to 180. If we subtract away the 4, 11x is equal to 176. And if I divide both sides by 11, x will equal, let's do a little long division, 11 into 176. 11 goes into 17 once, so there'd be 6 left over when I subtract. Bring down my other 6, and 11 goes into 66 6 times. There's my answer. X equals 16, and that's all they wanted me to work out. So these were supplementary angles. They form a linear pair. Hopefully you can see that they are not vertical angles. Angles 2 and 4 would be vertical angles, but this is angles 1 and 2. Therefore, they form a linear pair. Alright, number 12 is going to give us some practice naming angles. Alright, and they want us to name who? Angle 3. So I think lots of students mess up on this problem because they really don't even know which angle is angle 3. So do you see that right here it says angle 3? So they are talking about this angle right here. And if I had my pencil and I was taking the test, I would probably highlight this angle. Okay, so it actually looks like a right angle, right? And what's the rule for naming angles? Well, you need to put the angle symbol down, and then you're going to put what? A side point, then a vertex point, and finally a side point, like a point from the other side. So who is the vertex point? Can you see that this is the vertex point right there? So on all of these names, the point G has to be in the middle. So let's see, angle, and then I'm going to put G in the middle. So first, let's pick a point off this side. Do you see there's only one point on this side? It's H, so let's put H in. This side over here, though, has 2 points. It's got point A and it's got point B. And it doesn't matter. Either point tells you should look at this side. So I'm going to call this HGB. And of course, it's real easy to make a new name by just switching these around, right? These two can just be moved. So we could call it what? Angle BGH, and that would describe the angle. All right, let's do another one. Well, HG, instead of using B, let's use A this time. B, oops, my bad. That's going to be what? HGA. And of course, we can just go the other way. AGH, angle AGH. What if someone wanted to call this angle G? Well, if I said angle G, would you know if I was talking about this angle or the straight angle? Can everyone see whenever there's more than one angle at a vertex point, you can't name it just using that vertex point. You have to use this 3-point method. Alright, number 13 gives us a diagram, and they tell us a couple angles have some measures. Probably a good place to start would be to put that information right there on the drawing. So angle HFG, which one is that? HFG is this angle right here, and what do they say about it? It measures 39 degrees. Alright, then they tell us that this angle JFG, this red one right here, it measures 39 degrees. And then it says Maria believes that ray FG, which one is ray FG? Ray FG, maybe I'll go green on this one. This is ray FG. Is what? the bisector of angle HFG. All right? So is it possible that this is the bisector? Well, here's kind of the whole idea. You have to know what an angle bisector would do to the whole angle. Well, what does it do? It cuts it perfectly in half so that the small angles are the same. Are the small angles the same? Yes. So if I were writing out a description, I would say something like these two angles, the small angles, but I would actually name them if I were taking the test. The small angles created by the ray FG have equal measures, so it is an angle bisector. And basically you just need to know what an angle bisector does. Now what if one of these was 39 and the other one was 38? Would it be an angle bisector? No, right? It has to be perfectly right in the middle and cut the angle into two equal pieces. If they're not equal, it's not an angle bisector. All right, number 14 gives us a pre-image triangle, triangle ABC, and they ask us to reflect triangle ABC across the line x equals -2 to create its image, triangle A prime, B prime, C prime. And let's see, job number 1 is to draw the line of reflection. Now this is the most important part of a reflection. You basically get that line in the right spot, you're good. So the line x equals -2. There are lots of ways to come up with the correct line, but one of my favorite ways is just to create 2 points. Okay, and what's the only thing this equation cares about? That the x values are -2. So I'm going to fill in x values of -2. What if it said the line y equals 5? Well, then I would put 5s into the y values. So next up, it doesn't really matter. This equation doesn't care about the y values at all. I'm just going to use my favorites. You can pick anything you want. I always pick 1 and -1. And now I'm just going to plot those 2 points. So -2 up 1 would be there, and -2, -1 would be there. And I can clearly see that this is a vertical line. And I'm going to draw that vertical line in right there. All right, so part A, draw the line of reflection. Check, I've done that. Now we're going to reflect triangle ABC and label its image A prime, B prime, C prime. And all we have to remember is to go exactly the same distance. So how far is point A from the line of reflection? 1 unit. I'm going to go 1 unit over. Right there will be A prime. In fact, let's figure out where A prime is. Now be careful. You don't want to use your line of reflection. You're going to actually count from the origin. So wouldn't this be 1, 2, 3? It's -3. And how far down is it? 1, 2, 3. There's A prime. It's at -3, -3. All right, let's do point B. So how far over is it? 1, 2, 3, 4. I'm going to go 1, 2, 3, 4. There is point what? B prime. And it's over what? 2. It's over 2 and it's down 1, 2, 3, 4, 5, 6, 7 to -7. To -7. I'm kind of filling in these coordinates on part C. I do still need to draw this in when I'm done, but I'm not done with point C, right? So how far away is point C? 1, 2, 3, 4, 5, 6. Time to go 6 on the other side. 1, 2, 3, 4, 5, 6. There's the spot. This is C prime, and it's over what? 4 and down 1, 2, 3, 4. Down 4 and +4 and -4. All right, and the last thing I should do is draw in my image. So connect the points. And you always should know whether you did it right. How can you know whether you did it right or not? Well, reflection is a rigid motion transformation, and my 2 triangles should look identical to each other, just flipped over, right? All the segments should look the same length, all the angles should look the same, and they do. So we worked that one out correctly. Getting that line in the right spot is the biggest part of doing any reflection. All right, number 15 asks us to explain the difference between a rigid motion and a non-rigid motion transformation. Alright, so let's say we have some pre-image. In this case it's a triangle. What a rigid motion does is it comes over here and makes a copy of the pre-image and it just moves it over. Or maybe it, let's see if I can get, doesn't want to, there we go. Or it spins it, right? But it really doesn't change it at all. Okay, so rigid motion, the word rigid basically means frozen. So the shape is frozen even though I'm going to move it. That's what rigid motion is. Just move it around, but don't change what it looks like. Okay, so maybe you would say rigid motion creates congruent figures. Or you might say the segments and angles stay congruent. All of those things would be good things to describe for rigid motion. So what about non-rigid motion? Well, non-rigid motion takes your shape and it like grows it. Oh, that kind of looks funny, but you get the idea, right? It grows it or shrinks it. Maybe it makes it taller, okay, or makes it wider. So that means if it's non-rigid, maybe I'll do it in a different color. If it's non-rigid, then the segments or angles are not congruent, right? Like maybe it gets thinner and so the angle is smaller, right? That's a non-rigid. If there's anything at all that's different, it's a non-rigid transformation. All right, number 16 gives us this triangle with these ordered coordinates for their thing, and here's the key word. They want us to figure out the perimeter of the triangle. In other words, we basically have to figure out how far all the way around all three sides. In fact, if I just figure out how long each of these sides is and add them all up, that will give me the perimeter. And I could just count the squares, so I think I'm going to do that. So how long is this red segment? It would be what? 1, 2, 3, 4, has a length of 4. And how about the green segment? 1, 2, 3, 4, also has a length of 4. And here's kind of the big part of the problem. How do you figure out the length of zy? Well, we could use the coordinates of zy and use the length or distance formula, but I think I'm just going to use the Pythagorean theorem. Since I've got the red leg and the green leg, the Pythagorean theorem says what? Leg squared plus leg squared is equal to the hypotenuse squared. So if I say leg squared, that would be what? 4 squared plus the other leg squared, 4 squared, is equal to the length of my hypotenuse. Maybe I'll call it, I don't know, maybe I'll call it c. So this would be c squared. So how about 4 squared? That's what? 16 plus another 4 squared is 16 is equal to c squared. 16 plus 16 more would come out to be what? 32 equals c squared. But I don't want c squared. I just want the length of this, c. So I'm going to take the square root of both sides. And that means c is going to come out to be, that's not a perfect square, so we just get square root 32. So this is square root 32. And now to get what? The perimeter, I just need to add up all 4 of these. And the deal is, you can add up the 4's, but you can't add up the square root 32. So, to get the perimeter, 4 plus 4 would be what? 8, plus this side that's not just a regular whole number, square root 32. And that would be the answer you would want to bubble in on the test or write it out if it's an open-ended problem. Okay, so one way to do this would just be to use the Pythagorean theorem. You have to remember that doing perimeter means that you add up all 3 sides. Alright, number 17 gives us this triangle right here. This is actually going to be our pre-image, and we're going to use it to do both of these problems. Okay, so we're going to do one transformation here off of this pre-image, and then we're going to start from scratch again and use this again. Please be careful that you do that on the test. They'll have you use the same triangle. So don't get an answer from here and then like do this one from that one. Use this as the same pre-image both times. Alright, and they give us the transformation we're supposed to do right here, which basically says take whatever coordinates you have, leave the x alone but double the y values. So in order to do that we need to know some points. So obviously this one's at 0, 0, This is over 3 at 0, and this one is at 0, 3. So we're going to use these 3 points in this little formula. So let's start with the 0, 0. So what would 0, 0? Well, the x is going to stay the same. We have to do 2 times this y. Well, what's 2 times 0? It's still 0. So here is my first new point. Let's do 0, 3. Well, the x value is going to stay the same, so it's still going to be 0, but 2 times the 3 would come out to be 6. So 0, 6 would be right there, right? You just use this as a little formula. Whatever this says to do, you do that. And 3, 0, well, the x value is going to stay the same, and the y value is going to get doubled. So what is twice 2 times 0? Still 0. So over 3 right there. And maybe I'll draw in my new triangle. Okay, so here's the question they ask us. Is this a rigid motion or not a rigid motion? Well, are these two triangles perfectly the same in every way? No way, right? This is not rigid. And what's the problem? Well, the segments are not congruent, right? This is what, 3 units long? This thing's 6 units long. That changed, so it's not a rigid motion, right? In fact, it got what? Vertically stretched is what happened. Okay, now we're going to come down here and do this transformation right here. And it says that we're going to take the x values and subtract 5 and the y values and add 2, and we're just going to do exactly what we did before. So 0, 0. What if I did 0 minus 5? That would give me negative 5. And what if I did, what's my 0 plus 2 would come out to be that. So I'm going to go negative 5 up 2. There's my new point. Okay, I got that one done. Now let's do 3 zeros. So this would be what? 3 minus 5. That comes out to be negative 2. And 0 plus 2 would be positive 2. So negative 2 up 2 would be right there. And last one, 0, 3. So 0 minus 5, that would be negative 5. And 3 plus 2 would be positive 5. So negative 5 up 5 would be right there, and I will draw in my triangle. And now the question is this triangle congruent, perfectly identical to this one up here? Well, do you notice this is 3 tall, this is 3 tall plus? Hopefully you notice that this was just a translation. All it did was slide this triangle over 5 and then like up 2. That's all it did. So this is definitely a rigid motion. Alright, number 18 gives us this pre-image, and they're actually going to have us do 2 things on this problem. Part A is going to make us reflect triangle ABC and get an image, and then this is what we'd call a composition, because when we're done, we're going to actually take that new image and use it as the pre-image for a rotation. So we're going to reflect this triangle, get a new version of it, and then rotate that new version. Okay? So let's do the reflection first. It says that we should reflect across who? The x-axis. So here is the x-axis. Let's go ahead and do this reflection. So down 2, so down 2 right there. Okay, this is what? Down 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4. Alright, so I get this point. Who is this? A prime. This is B prime, and let's do C. 1, 2, 3, 4, 5. So I need to go 1, 2, 3, 4, 5. There is C prime, and I will draw in the triangle. Alright, and if I did it correctly, the 2 triangles should look like a rigid motion, because reflection is a rigid motion. Okay, so the reflection is done. Now I'm going to take this red image triangle and rotate it 90 degrees clockwise around the origin. So step 1, plot a point at the origin, and I am going to connect point A with an L-shaped figure. Here I go over and down. That's like 4. That is 4 by 2. And if I'm going to go, what, 90 degrees counterclockwise, I would rotate up, and it's still going to be what? Up 4 and over 2. There's my new point, and this isn't A. It's not A prime. It's A double prime. And where is it? It's at, actually we don't even have to write coordinates, right? That's just going to be A double prime. Okay, let's do another one. I think I'm going to do point C. So, no, I'm going to do point B. So over and down, this is what? 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 7 by 4. If I flop that up, it's going to be what? Up 7 and then over 4. 1, 2, 3, 4. There is the point right there. There is what? B double prime. And finally, let's do point C. I think I'm going to go this way this time. Down and over. That's 5 by 5, 5 by 5. So if this thing rotates over, it's going to be over 5 and up 5. And actually point C is going to land right, C double prime is going to land right where it was before. And let's draw in the last triangle. We should get something that looks like, oops, I just went from the wrong spot. Yep, I did. Let me redo that. It's going to be right here. That's where my triangle would end up if we rotated 90 degrees. So you just do one and then take your time, do 1 point at a time. Number 19. Number 19 gives us the triangles, and here's what they say. ABC is a rigid motion translation of triangle DGH. So rigid motion, that means these two are perfect copies of each other. In fact, that means that segment AB and segment DG are perfect copies of each other. Segment BC and segment FG would be perfect copies of each other, and segment DF and segment AC are also perfect copies of each other. What if I told you segment FG had a length of 10? Well, then segment CB would also be 10. And what if angle D over here had a measure of 43 degrees? Then angle A would also have a 43-degree angle, because that's what rigid motion means, right? They're perfectly identical. They've just moved. All right, so here's the rest of the problem. Right down here, they tell us that segment DF has a length of 5x minus 12, and I'd actually be smart to just write that on there. Segment DF has a length of 5x minus 12. And the next thing they tell me is that segment FG right here, FG, who is FG? FG is right here, has a length of 3x minus 6. And finally, they tell us that segment AC has a length of 4x minus 3. So segment AC right here, 4x minus 3. All right, so can you hopefully see really easily that that DF and AC are in the same spot, so those two must be equal? All you have to do is notice that these are the two that should be equal. Some students try to make an equation out of the whole thing. Can you see that FG really doesn't match with anybody? It's these two green segments. So if you write the equation, 5x minus 12 has to be exactly the same as 4x minus 3. You got the idea of what's happening with the rigid motion. That those sides have to be the same, so we can say that they're the same. All right, let's do a little algebra and we'll have our solution. I'm subtracting 4x from both sides. So 1x minus 12 equals negative 3. And finally, when I add 12 to both sides, I end up with x equals 9. And that's all they wanted. And if we wanted to explain our reason, I would write that rigid motion makes segment FG's length, or DF, segment DF's length equal to segment AC's length. That's what I would write for my reason. Number 20 gives us the fact that point Q is the midpoint of segment RS. So here is the first fact they give us. This is kind of a little geometry statement with no picture. So guess what I would be smart to do? Is draw my own picture. So here comes segment RS. So I'm going to label these endpoints R and S.
And this time they say, what about Q? It's actually the midpoint. So I'm going to try to put point Q right in the middle. And if it really is the midpoint, then this segment would have to be what? Congruent to this segment over here. So that when they tell me that segment RQ has a length of 3x plus 19, and segment QS has a length of 7x minus 9, if I know what a midpoint does, I'll know that those two segments are congruent. So it says draw a diagram that shows points R, Q, and S, and label the diagram with all the given information. I've done that. Now they want the value of x, which basically means make an equation. They don't tell you to make an equation, but that's the way you figure out what x has to be. And if this is really in the middle, then 3x plus 19 would have to be equal to 7x minus 9. Alright, now that we've got the equation made, we'll just do a little solving. I'm going to subtract 3x from both sides. So 19 is equal to 4x minus 9. I will add 9 to both sides. So now 4x is equal to 28. So that if I divide both sides by 4, I get x equals 7. So the value of x, I just worked it out, x equals 7. Alright, here is maybe a sneaky part of this problem. They want the length of segment RS. So the length of segment RS from R all the way over to S. Do you notice we could plug in the 7 and figure out how far both of these small segments are? And if I know both of those small ones to get the whole thing, I could just add them together. So that's what we're going to do. So 7 times x, and what's x? 7. So 7 times 7 would be what? 49 minus 9. That comes out to be 40. Now before I even work this one out, it needs to come out to be 40, right? If this is really in the middle, these two sides will be equal. So let's see, 3 times 7 would be 21 plus 19, and that does add up to 40. Now what would the whole thing be if each side is 40? We would say what? RS has a length of 80. And all of this is just based on you knowing what's going on in geometry when you have a midpoint.
It might help you in the morning, like usually if your back hurts.
Alright, number 21 gives us this triangle, has some markings on it, and they say give correct geometry names for the items below. So they're going to ask us to find 4 things, and we just have to name them using what we've learned about naming things in geometry. So the first thing they want is a segment bisector. In other words, we need to find something that cuts a segment in half. Well, do you notice right here there's some tick marks on these two segments? In other words, segment AB right here is kind of minding its own business, and then this segment comes down, and of course the tick marks say what? It kind of cuts it perfectly in half. So actually, I think you could say 2 answers. Well, point D you could consider a segment bisector, and if you want to name a point, you just put a capital letter, right? But we could also say that this segment right here, segment CD that comes down, is also a segment bisector. So how would you name that? Well, it's a segment, so we would say something like segment CD. So either one of those you could consider a segment bisector. Alright, now they want 2 segments that are perpendicular with each other. Well, what does perpendicular mean? It means 2 segments or angles or rays that make a right angle. So do you see that this makes a right angle? So I think we can just go ahead and say perpendicular means makes a right angle. So what 2 segments make a right angle with each other? I think I'm going to say something like segment AB and segment CD. Those make a right angle. That's what perpendicular means. A midpoint. Alright, well, there's the tick marks again. So who is the midpoint? Right there, point D. You could call it a segment bisector, but that's what a midpoint does. It bisects the segment. Okay, finally they want 2 right angles. Well, if this is a straight angle, a straight line, and this is a right angle, well, this would also be a right angle. So if I can just name these 2, so how about the one over here on the left? I would call it what? Angle ADC, because point D is the vertex and has to be in the middle. ADC. And the other angle would be this one over here. We could call it what? Angle BDC. Angle BDC. C. Alright, so you got to know words like perpendicular and right angle and how to name an angle and what a segment bisector are. If you know those definitions, you'll be able to get this. You need to know what these tick marks are trying to tell you, all of those things. Alright, number 22 tells me I've got angle A and B and that they are supplementary. So pretty much if you know what that word means, you're in good shape. Well, what does it mean if two angles are supplementary? It means that if you add them up, it comes out to be supplementary. What is that? 180 degrees. Okay, so if angle A and B are supplementary, and then angle A measures x minus 7, and angle B is 2x minus 2, but they got to add up to 180, I can make an equation out of that. I can say that x minus 7 plus angle B, 2x minus 2, all adds up to 180 degrees. And now I just have an equation to solve. So x and 2x would make 3x. A negative 7 and a negative 2 would make negative 9. Is all equal to 180. I'll add 9 to both sides and get 3x equals 189. And if I divide both sides by 3, I should get my x. So let's see, what do we get here? 3 into 189. Well, 3 goes into 18 6 times. That would be none left over. I'll bring down my 9, and 3 goes into 9 3 times. So x equals 63. Now, here's the trickiest part of this problem. It is like this on the test. They don't want x, right? It doesn't say what's solve for x. It doesn't say that. It says what? Find the measure of angle B. Oh, how do I do that? Well, angle B equals 2 times x minus 2. So all I need to do is take my 63 and plug it in and work out what angle B is. Now, one of the answer choices will be like 63, so you gotta like not be in a rush. Make sure you're noticing that it's asking for angle B. So it's going to be what? 2 times x minus 2, and my x value is 63. 63 times 2 comes out to be what? 126 minus 2 gives me 124 degrees for the measure of angle B. Alright, that was all the problems on the practice test. If you do your best to understand why each one works out the way it does, you might even cover up all your answers and say, okay, how would I do this problem? And then pull your hand up. Just doing the problem doesn't mean you will know how to do it on test day, so you might need to do some extra studying. But good luck. Hopefully watching this video got you that much more prepared.